semester. Today we will discuss the UV-Vis spectrometer, the Carry 50. You come over, we have a xenon lamp within this instrument that shines light from 200 to 1,000 nanometer wavelength light. That light passes through a grating, which then makes the light monochromatic, meaning only one wavelength at a time will pass through this grating. When that light travels through that grating, it will pass here, and it will go through your sample, which will be held in a cuvette. As the light passes through, some of your sample might absorb the light, and that light is picked up by a fiber optic, which then travels to a detector, which then measures any changes in light intensity. Coming up next, we will go over serial dilutions. Hello. Welcome back. And today, we'll continue going over what you'll be doing in your first lab. Starting off, the calculations that you'll be doing consist of Beer's law, in which you need solutions that have absorbances between 0 and 1. As you can see, sometimes you start with solutions that are much too concentrated and too dark to get those nice absorbances, like so. So we need a way to efficiently dilute this down so we can get within that range. And the easy way to do it is through a serial dilution. Now, a serial dilution is when you start with a stock solution and then you sequentially dilute it by half over and over again. This way you get a wide range of concentrations that you can use in your lab. And Sebastian's about to show us how to do that. So using your pipette that you will have, which is 10 mils, you'll then affix the ball to the top of the pipette. By squeezing the ball, it sucks in air and then you'll be able to draw up your liquid. And there's a marker on the pipette that will tell you when you've reached the 10 mils. So as Sebastian carefully does this, he is able to draw up the stock solution. And he is able to dispense it in one of the flasks that will be provided. Notice how all the liquid is being expelled from that pipette, even the little droplets at the end. So now we need to dilute it, and the solvent that we'll be using is water. So now he'll begin his 50-50 dilution. Now, as you noticed previously, there was also a lot of residue left over in the pipette, and you'll need to rinse out the pipette between each addition. Now, adding the water to the solution, we are beginning to make our first concentration, which is a half dilution. And now, to continue on with the serial dilutions, he would take 10 mils of that newly formed dilution and add it to a new flask, and then once again add 10 mils of water. He'll continue to do this until we have reached the appropriate ranges of absorbances from 0 to 1. Now, coming up next on TA with Tom, we'll be going over how to actually use the spectrometer and use the cuvettes that are associated with it. Oh, hello there. Oops. Nope. Today, we'll finally conclude by actually how to take a spectrum. To start off, we want to open the program that the spectrometer uses. You'll simply go to Start and hit Scan right here. Now, I already have the program open. So, here's what you'll be using. To begin, there's a Setup button located on the top left. And when you click that button, it gives you a wide range of parameters that you can use to help edit how the spectrometer will run. So we don't need to change anything here, so simply press OK. You also have a 0 option here, which will zero out the absorbance that you see up here. And it'll give you a number close to that of 0. But to really begin, we want to take a spectrum of our blank, or solvent, which in this case is water. My good friend Ben here has already loaded up the cuvette to the proper line amount on the cuvette. So there's enough solvent for the spectrometer to read. He'll now place it in the spectrometer in the sample holder. Make sure to wipe the cuvette between each run in order to make sure there's no finger residue that could have get in the way of your scans. Moving it, facing the cuvette where the small clear side can see the light is crucial, and place it properly each time. Now that the sample is loaded, we can take a scan of our blank. Simply just press Start. Here, you'll just write in the file name. So I will write my name and blank. Pressing Enter, you can now, it'll say Sample 1. Once again, you can just type in blank and hit OK. It is now taking the scan. as you can see, there is some absorbance towards the UV region. But now we really want to take a scan of the dilutions that Sebastian did earlier for us. So beginning, we want to remove our blank. And now, remembering to wipe the cuvette, we will once again place the sample within the spectrometer, facing the proper way, and closing. Now we can take our scan. Once again, simply press start. Now it's not blank, and we'll actually write Tom and sample 1. And instead of blank, we'll write sample 1 and take our scan. As you can see, there is a peak here which corresponds to the lambda max, which is an excitation that occurs within the molecule. This will be the peak of interest. As you can already see, this has an absorbance of above 1. Thus, this concentration is unusable for your calculations. So you'll have to continue taking scans of your sequential dilutions in order to get that peak below 1. Thank you for stopping in today. I'll see you next time.